Homolog series of alkene. General formula of alkene is CnH2n and refer to the number of carbon atom per unit molecule, and starting from 2. Type of hydrocarbon, alkene is unsaturated hydrocarbon because in one molecule of alkene has at least one double covalent bond between two carbon atoms. Double covalent bond can be formed, minimum need 2 number of carbon atom. This double covalent bond cannot be formed between carbon atom with hydrogen atom. So here functional group for alkene is one double covalent bond between two carbon atom. Ending name of alkene group is ene, E-N-E. Both source and users of this homolog series same like the homolog series of alkene. The members of homolog series of alkene starting with ethene, propene, but-1-ene, pen-1-ene, and others. How to get the molecular formula of ethene? And we refer to the general formula and refer to the number of carbon atom per unit molecule. So ethene has 2 number of carbon atom per unit molecule. So when we put into the general formula, C2H2 times 2, 4. So the molecular formula of ethene is C2H4. Based on the molecular formula, how can we get the structure formula of ethene? Ethene has 2 number of carbon atom. We draw 2 number of carbon atom. Between 2 number of carbon atom present 1 double covalent bond. So each carbon atom sharing 2 pair of electron between them, and each carbon atom has another 2 valence electron. Here 2 valence electron, and here 2 valence electron, which can form single covalent bond with another 4 hydrogen atom. This is the structure formula for ethene. How to get the condensed structure formula for ethene? We refer to the structure formula. CH2 double covalent bond CH2, or we can write CH2 CH2. How to draw the structure formula for propene? Propene has 3 number of carbon atom per unit molecule. So we draw here 3 carbon atom, and we know that in one molecule of propene contain 1 double covalent bond. So we put here double covalent bond, and we know that around carbon atom need to share 4 pair electron. So another 2 valence electron sharing with other 2 hydrogen. Same like this carbon. 2 pair electron already share with this carbon atom or carbon number 1, and another pair of electron sharing with carbon number 3. So here this carbon number 2 already share 1, 2, 3 pair of electron with other 2 carbon atom, and balance is 1 electron, so sharing with another 1 hydrogen atom. And the last one, carbon number 3, need to share 4 pair electron around. So 1 pair already share with carbon number 2 and balance electron 3. need to share with 3 hydrogen atom. 3 hydrogen atom here. 1, 2, 3 hydrogen atom. Okay, the structure formula for both 1 in. And both 1 in contain 4 number of carbon atom per unit molecule. So we put here 4 number of carbon atom. We label number each carbon atom, carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So we put double covalent bond here at carbon number 1, and around this carbon another 2 pair of electrons sharing with 2 hydrogen atom. For carbon number 2, 3 pair of electrons sharing with 2 carbon atom, and another 1 pair sharing with hydrogen atom. Carbon number 3, 2 pair already share with 2 carbon atom, and another 2 sharing with other 2 hydrogen atom. And the last one, only 1 pair of electrons sharing with carbon number 3, and other 3 pairs sharing with other hydrogen atom. So this is the structure formula. To write the condensed structure formula, we refer to this structure formula: CH2 double covalent bond, CH, CH2, CH3. This condensed structure formula represent of this double covalent bond. We know this molecule or this substance is members of homologous series alkene. So both 1 in, number 1 here, pen 1 in, number 1 here, represent as the location of double covalent bond in the molecule. So basically double covalent bond, basically we put at the carbon number 1. So double covalent bond here present at carbon number 1. For the long chain, this long chain, the double covalent bond must be at the nearest carbon. We can also put here because the molecule can be rotate 180 degrees and 360 degrees. So still the same molecule when we put here. But when we put here, we need to number the carbon atom starting from here, because double covalent bond present at the nearest carbon along the chain. So put 1 in, because double covalent bond present at carbon number 1. Physical properties of homologous series of alkene in terms of melting point and boiling point, density, solubility, and electrical conductivity. When going down the homologous series of alkene, the physical properties increases because of the increasing of the number of carbon atom per unit molecule. It's same like the homologous series of alkene. About the chemical properties of homologous series of alkene, we have 3: combustion, additional reaction, and polymerization. For the first one, combustion of homologous series of alkene, same like homologous series of alkene, complete and incomplete combustion. But the additional reaction here, number one, addition of hydrogen, addition of halogen, addition of water, and addition of acidified potassium manganate 7 solution. How the mechanism reaction in additional reaction? We use addition of hydrogen reaction to study the mechanism of additional reaction. We use ethene as an example. Ethene react with hydrogen gas. The condition is platinum or nickel act as a catalyst in higher temperature, 180 degrees Celsius. How to predict the product? Okay, we need to draw the structure formula of the reactant. So this is the structure formula for ethene. C2H4, C2H4, double covalent bond, react with hydrogen molecule, 2 hydrogen atom sharing 1 pair of electron to form single covalent bond. So during the reaction, all the addition reaction will focus on the carbon which exists the double covalent bond. This double covalent bond, one single covalent bond will break down and each carbon atom will receive it 1 valence electron to ready sharing 1 pair of electron with other atom. So here 2 hydrogen atom, this single covalent bond will break down, each hydrogen atom will receive it valence electron. So here this hydrogen atom 1 valence electron, this carbon atom 1 valence electron, so carbon will sharing 1 pair of electron with this hydrogen will form single covalent bond, and the one carbon atom will sharing 1 pair of electron with another 1 hydrogen atom and to form single covalent bond. So, carbon number 1 sharing 3 pair of electron with 3 hydrogen atom, and carbon number 2 sharing 3 pair of electron with 3 hydrogen atom, and these 2 carbon atom number 1 and carbon atom number 2 sharing 1 pair of electron to form single covalent bond. So this C1 sharing 3 pair of electron with 3 hydrogen atom, and C number 2 sharing 3 pair of electron with 3 hydrogen atom. So it will become ethane. So this reaction or this additional of hydrogen will change ethene to ethane. Addition of halogen, or we can call halogenation. Halogen refer to fluorine, chlorine and other element or members in group 17 of element. For the example, when alkene react with chlorine, it will produce chloroalkene. When alkene molecule react with bromine, it will produce bromoalkene. When alkene react with iodine, it will produce iodoalkene. The reaction occur at room condition. How the mechanism of reaction? We must draw the structure formula for ethene here and structure formula for chlorine molecule. C1 and C2 is double covalent bond. The single covalent bond will break down and carbon number 1 will receive its valence electron and same as carbon number 2. At the same time, chlorine molecule, the single covalent bond will break down and each chlorine atom will receive its valence electron. So this carbon 1 ready to share 1 pair of electron with chlorine atom, and same as carbon number 2. It ready to share one pair of electron with another one chlorine atom. So we put here carbon sharing one pair of electron with chlorine atom, and here carbon sharing one pair of electron with another chlorine atom. This carbon number 1 sharing 2 pair of electron with 2 hydrogen atom and 1 pair with chlorine atom. Another one, carbon number 2 sharing 2 pair of electron with 2 hydrogen atom and 1 pair of electron with another 1 chlorine atom here. So this molecule we call 1,2-dichloroethane. Basic name chloroethane. From ethene change to ethane because carbon number 1 and carbon number 2 sharing 1 pair of electron. That is the functional group for alkene. Chloro come from reaction with or additional with chlorine. Di come from how many chlorine? 2. When 1 chlorine atom, mono. 2 chlorine atom, di. 3 chlorine atom, tri. In this molecule, 2 chlorine atom, so we put dichloro, 2 chlorine, dichloroethane. So how about this number 1 and 2? 1 and 2 come from the number of carbon atom which present the chlorine. Carbon number 1, the existing of chlorine atom, and carbon number 2, the existing of chlorine atom. So 1, 2, dichloro, 2 chlorine, dichloroethane. Last example, we used to study the mechanism of reaction in additional of reaction. This additional of water, we can call it hydration. When alkene react with steam under high temperature at 300 degrees Celsius and 60 atmospheric pressure, in the presence of phosphoric acid act as a catalyst, will produce alcohol. So how the mechanism of reaction? Here is the structure formula for ethene. Here is structure formula for water. During the reaction, this double covalent bond, one single covalent bond will break down and each carbon atom will receive its valence electron to sharing electron with other atom. In this case, one molecule of water will break down this single covalent bond and receive one valence electron, and carbon number 1 will sharing 1 pair of electron with hydrogen atom, and carbon number 2 will sharing 1 pair of electron with OH. So here is the structure formula for alcohol form. This is the homolog series of alcohol when carbon atom sharing 1 pair of electron with OH. C1 and C2, sharing 1 pair of electron is the homolog series of alkene. So addition of water or hydration will change alkene to alcohol. Here ethene to ethanol. Polymerization of alkenes. Basic knowledge is the meaning of monomer. To show the polymerization, the molecule of alkene is called a monomer. What is monomer? It's a molecule that form the basic unit for polymers. What is the definition of polymers? Is a substance or material consists of very large molecules or macromolecules composed of many repeating subunits. So how to show the polymerization of alkenes? Take the example, propene undergo polymerization, temperature 100 to 300 degrees Celsius and 100 atmospheric pressure. Okay, first we need to focus on the two carbon atom which present double covalent bond. So we need to draw double covalent bond. The hydrogen here, and left and right of the chain be good to empty. So this hydrogen put down, and this one we put up or down. CH3 and hydrogen. Okay, what happened? This covalent bond, the single covalent bond will break down and carbon number 1 will receive its one valence electron, and also same like carbon number 2. This valence electron ready to share one pair of electron with another same molecule like this. So we just write the polymerization, the condition under temperature 100 degrees Celsius to 300 degrees Celsius, 100 atmospheric pressure, and we draw the same molecule like this. C, single covalent bond with another one C, hydrogen atom, down, hydrogen atom, up here, hydrogen atom, another one, CH3, or you can also draw like this. Just make the bracket here, and this valence electron ready to share with another unit of monomer. Another one valence electron ready to share with another monomer, and just put N. N is the number of unit of monomer. For polymerization of alkene, the monomer is propene. After undergo polymerization, it will form polypropene. Polypropene. This how the mechanism of the polymerization.